Welcome back, students. Today is the session 21 of JEE Physics. The chapter is current electricity, and I have taken this question which was asked in the JEE mains examination in 2014. The question is, in the circuit shown below, the current in the 1 ohm resistor is. There are four options here. The first option is 1.3 amps from P to Q. The second option is 0 ampere. The third option is 0.13 ampere from Q to P, and the fourth option is 0.13 ampere from P to Q. So in order to solve this question, I will be using the Kirchhoff's loop rule. I will be using the Kirchhoff's loop rule, which says that the algebraic sum of the potential difference across each resistor the algebraic sum of the potential difference across each resistor and the external EMF source in an electric circuit is equal to 0. So I will be using the Kirchhoff's loop rule, which says that the algebraic sum of the potential difference across each resistor and the external EMF source external EMF sources in an electrical circuit is equal to 0. So with the help of this loop rule, we will be able to find the current which is flowing in the 1 ohm resistor. So this is the definition of this Kirchhoff's loop rule. That is, the algebraic sum of the potential difference across each resistor and the external EMF sources in an electrical circuit is equal to 0. So here in this question, as you can see that we have to find the current which is flowing through this 1 ohm resistor, and for solving for this question, what I have done is that I have denoted these points in this electric circuit as this is a point M, this is a point N, this is the point R, and this is the point S. P and Q were already given in the question. So now using the Kirchhoff law, this loop rule, I will be finding the current through this 1 ohm resistor. So first, in the first case, I will be taking the loop PQ, P, R, S and Q. So this for the loop PRSQ, P, PRSQ. So I am taking this loop in the first case, and for this loop, let us say the current which is flowing in this through this this EMF source is, let us say, I. So the same current will be flowing through this resistance also. Now let us say the current which is flowing through this 1 ohm resistor is I1. So if the current which is flowing, if the current which is flowing through this 3 ohm resistor is I, and if the current which is flowing through this 1 ohm resistor is I1, then the current which is flowing through this 3 ohm resistor will be equal to I minus I1. Okay, so now for this loop PRSQ, using the Kirchhoff's loop rule, that is the algebraic sum of the potential difference across all the resistors plus the potential difference across the external EMF source will be equal to 0. So here the potential difference across this external EMF source is 9. I have taken the current which is flowing in this circuit as here the current is flowing is I. So this current will be flowing through this 3 ohm resistor also. The potential difference across this 3 ohm resistor will be equal to 3 into I. Now the current which is flowing through this 1 ohm resistor is I1. So the potential difference across this resistor will be equal to, that is equal to 1 ohm, that is 1 into I1, that is equal to I1. Now here this current, the current which is flowing here is I minus I1. Now at this junction, this I minus I1 and this current which is flowing through this 1 ohm resistor is I1. So they will be meeting at this point Q. So if I apply the Kirchhoff's junction rule, the junction rule says that Kirchhoff's junction rule, let us say this is the current which is flowing towards the junction, and this is the current which is going out of the junction, and let us say this is the current also, this is going out of the junction. So as per the Kirchhoff's junction rule, the sum of the current which is the sum of the current entering a junction will be equal to the sum of the current leaving the junction. So I will be using the Kirchhoff. So by using this Kirchhoff's junction rule, the current here at this point, that is means the current which is flowing through this 1 ohm resistor is I1, and the current which is flowing through this external EMF source is I minus I1. So these two currents, they meet at the point P, and finally what will happen? I will be getting the current ahead of P as I, because the sum of the current as per the Kirchhoff's junction rule, the sum of the current entering a junction. So here you see the sum of the current which is entering the junction is equal to I1 plus I minus I1, and this will be equal to the sum of the current leaving the junction. So this is the current which is leaving. So the sum, the current which is leaving the junction will be equal to I1 plus this I minus I1. So this is equal to I. So the current which is flowing across this 2 ohm resistor will be equal to I. Okay. So now, so I am first of all, what I have done is I have taken for the loop PRSQ the potential difference across this EMF source is 9. The potential difference across this 3 ohm resistor, this resistor is equal to 3I. The potential difference across this 1 ohm resistor is equal to this is I1 into 1, that is equal to I1, and the potential difference across this 2 ohm resistor will be equal to 2I. and this is equal to 0. So the what we are getting, the equation is, that is 9, that is 3i plus 2, that is equal to 5i. 5i plus i1 plus 9, which is equal to 0. So this is the first equation which I have got using the Kirchhoff's loop rule. Loop rule and the junction rule also. I applied the junction rule at this point P. That is, the sum of the current entering a junction is equal to the sum of the current leaving the junction. So by using that junction rule, the current which will be flowing through this 2 ohm resistor is equal to I. So the first equation which I have got is, using this Kirchhoff law, is 5i plus i1 plus 9 is equal to 0. Now I will be taking another loop. Let us consider this loop. Consider the loop MPQN. MPQN. So in this loop, the potential difference across this 3 ohm resistor is equal to 3i minus i1, because the current which is flowing through this 3 ohm resistor is equal to I minus I1, and the potential difference across this external EMF source is 6. And now here, if you take this loop here, the current here is flowing in this direction, but in this resistor, the direction of the current is opposite. So in this case, what I will be doing is, the potential difference across this resistor will be taken as negative, because the current which is flowing in this loop has been taken in this direction, that is in this direction, like this. So if I am considering the direction of the current as this, then the potential in this loop, the direction of the current which is passing through this 1 ohm resistor is opposite. It is just the direction of the current which is flowing through this 1 ohm resistor is opposite to the direction of the current which we have taken in this loop. So in this case, the potential difference across this resistor will be taken as negative. So this will be equal to I1 into 1, which is equal to I1, and this is equal to 0. So 3i minus 3i1 plus 6 minus I1 is equal to 0. So here I am getting it as 3i minus 4i1 plus 6 is equal to 0. So this is the second equation which I have got using the Kirchhoff's loop rule. That is 3i minus 4i1 plus 6 is equal to 0. So I have got two equations, and with the help of these two equations, we will be able to find the value of the current which is flowing through this 1 ohm resistor. So we have to basically find the value of I1. So I have got these two equations, that is 5i plus I1 plus 9 is equal to 0, and the second one is 3i minus 4i1 plus 6 is equal to 0. So now we have to eliminate I, because we have to find the value of I1. So for elimination, what we can do is, I can simply multiply this equation by 3 and this equation by 5. So if I multiply, let us say this is equation number 1 and this is equation number 2. So multiply equation 1 by 3 and equation number 2 by 5. So what we will get is, we will get, that is, if I multiply this, that is equal to 15i plus 3i1 plus 27 is equal to 0. And if I multiply the second equation by 5, I will be getting as 15i minus 5 4 20 I1 plus 30 is equal to 0. Okay, so now let us say this is the equation number 3 and this is the equation number 4. So now what I will do is I have got these two equations, so we can write these two equations as 15I plus 3I1 plus 27, that this was equal to 0, minus minus 15I minus 20I1 plus 30. So this would be equal to 0. So it implies that if what I have done is I have subtracted this value, means I have subtracted this 15I plus 3I plus 27 is equal to 0, and so what I have done is I have taken these two equations and I have subtracted this one, that is equation number 4 from this equation number 3. So what I am getting here is that is equal to 15I minus 15I, which is equal to 0, and 3I 1, and this is equal to plus 20I1 plus 27 minus 30 is equal to 0. So it implies that 23I1 minus 3 is equal to 0. It implies that I1 is equal to 3 upon 23 ampere. So this is equal to, if I just calculate it, 3 divided by 23, so this will be equal to 0.13 ampere. So the current which is flowing through this resistor, that is the 1 ohm resistor, is equal to 0.13 ampere. Now, since the value of this current is positive, therefore the direction of this current which we have taken as from Q to P will be the same. That is, the direction of the current will be from Q to P, because the value of this current is positive. If the value of this current was negative, then the direction of current would have been from P to Q. So in this case, the value of the current through this 1 ohm resistor is equal to 0.13 ampere, and since its value is positive, then therefore the direction of the current will be the same as we have taken in this loop. The direction of the current which we have taken in this loop is from Q to P. You can see it here in the figure. So therefore the direction of the current will be from Q to P, and its value is equal to 0.13 ampere. So 0.13 ampere from Q to P so this is the correct option. So the correct option is C. Okay? So this is how this question needs to be solved. This question was asked in the JEE mains examination in 2014, and so we have solved this question using the Kirchhoff's loop rule and the Kirchhoff's junction rule. So thank you very much for joining this session. I hope you have understood the solution of this problem, and in the next session I will be coming up with few more questions from the same chapter, that is current electricity. So thank you very much again, and till then have a nice day. Bye.